Hello, Algebra 2. In this second day, we're going to look at some more examples of compound events. And first, we'll just warm up by deciding whether or not events are mutually exclusive. In other words, do they have overlap or events in common, or do they not have anything in common? Is everything completely separate? Sometimes that's even called disjoint. So let's look at these problems one step at a time. We're not going to do any math. We're just going to decide what kind of compound events they are. So the first one says we've got a basket containing 4 apples and 6 peaches, so some fruit. And it also says 3 of the apples and 1 of the peaches are rotten. So I'm already kind of thinking in my head the events are probably what kind of fruit we have and whether or not it's fresh or rotten. So it says you pick one piece of fruit, and it is, so suggesting like the probability that it's fresh or that it's an apple. What if we want to look at that compound circumstance? So ask yourself, are the events fresh and being an apple, are they overlapping or not? In other words, are there some apples that are also fresh? Well, they said 3 of the apples are rotten, so that leaves 1 that's fresh, so I think there's one outcome in common here. So these events, and you might call them being fresh and being an apple, are not mutually exclusive. Another way to say that is they are inclusive because there is an overlap. And if you want to be extra explicit, you could talk about how many elements are in that overlap. Since there were 4 apples and 3 of them were rotten, that means 1 of them is fresh. So I'm going to say specifically 1 apple is both fresh and an apple. So I should have put quotations here as well. So that's why they're inclusive. So let's put that and that, just to be extra nice and clear. Okay, here's another circumstance. You might pause the video now and try this one out on your own. We've got a litter of kittens, 3 gray females, 1 gray male, 1 black male, and 2 black males. So I'm already thinking in my head the events must be like color and male or female. So I could even write that down. But it says you pick 1 kitten, and you want to look at the chance that the kitten is gray or is male. So again, do these events overlap or not? Well, gray and male. Is there any kitten that's both? Right here. Right here is what we want to look at. It says there's 1 gray male. So I'm going to say since there is a kitten which is both a male and gray, there is some overlap between these 2 events. Again, we have 1 overlapping, well, let's say 1 element / kitten in common. Hence, the events are, again, inclusive or not mutually exclusive. So there we go. I'm just being nice and careful with the vocabulary as you guys are starting these out. I want to make sure I get that in bold. Okay, last one before we look at another math problem. So this one says there are 12 shirts in your closet. There's 4 blue ones, 4 green ones, and 4 red ones. So you must be a pretty boring person. All bold colors and no mixing and matching. Anyway, you select one to wear. What's the chance that it's blue or it's green? Well, since I think we've got solid color shirts here, I don't think there's anything in common. So I'm going to say since a shirt in this closet, at least, cannot be both blue and green, there don't appear to be any overlapping shirts, and I'm going to write this the same way I said before, set theory, elements, which in this case are shirts. Hence, or therefore, the events are mutually exclusive. And whenever you have mutually exclusive events, When you're doing OR probabilities, you're going to find that they're much easier to do, and you probably don't even need to draw a Venn diagram. So let's go and look at an application problem now and do some computations where we do have to draw a Venn diagram.